So the first part of the question asks us to find out dy by dt, which is basically the velocity of the mass. If we assume t root k by m to be a function called v of x, then v dash of x would be simply k root of k by m. In order to find out the derivative of the position with respect to time, we must use the product rule. So we know that v dash of x, which is dv by dt, is root of k by m, and we know that y is equal to y naught cos of v. That dy by dv is equal to y naught minus y naught sine of v. We now use this formula. So dy by dt is equal to minus y naught sine of t root k by m into root k by m. So this becomes minus y naught root k by m multiplied by sine of t root k by m. In order to evaluate or discern the answer for the same, we must simply substitute the new value of the mass. That is, the new mass is 4 times the initial mass, minus y naught root k of 4m multiplied by sine of t divided by k divided by root of 4m. So we can now simplify this equation in order to express the new condition with respect to the previous one. So we know that the coefficient of the sinusoidal function is now 1 by 2 into minus y naught into root of k by m into sine of t by 2 root of k by m. So what has happened basically is that the initial equation, all the values of y have been divided by 2. So if this was the initial oscillation, the maximum, the amplitude has now halved. This is in order to evaluate how the period has been affected, is to simply see how a sine equation or sine function changes when its components are halved. So basically, the amount of this is 1 revolution of a sine function. If that has been changed, if that has been halved, it implies that in the same duration as the initial function, the new function would only cover half the wavelength.